Dear students, I welcome you all to the online learning platform for the course Warehousing Automation. So, for the honors register course, you have been pursuing this particular course, and now we are in the last presentation for Unit 2. So, we have been learning this course through series of presentation. So, within which initially we started with Unit 1, then we migrated to Unit 3, and now we are discussing about Unit 2 queuing theory. And today's class will get into the last chapter, that is forecasting behavior and demand fluctuation, proactive identification and mitigation. So these all are the two chapters what we are going to see in this particular presentation. So now, before we get into the further topic of forecasting how all these things, so now we recollect the things what we learned in the earlier chapters, that is in this previous topics, in the previous lectures what we discussed. So the first thing is, warehouse itself is considered as a queue in which the incoming is going to be the service products, and the processing inside the warehouse is considered to be the queue system, and the products which gets shipped to the customer was considered to be outbound logistics, so in which a queue behavior is there. So we initially started the discussions with respect to the terms involved into the queue concepts, that is queue models. Okay, so namely we learnt about waiting time in a queue system and waiting line in a queue. So queue system and queue are not the same. So the population, queue population and the line population. So likewise service rate of the system, service rates inside the queue. So we solved problems in this regard, and we learnt about the modeling of a queue behavior involving Kendall's notation. So these all are the discussions what we had in the initial part, that is modeling a queue. So the next part was with respect to understanding the queue behaviors, that is involving men. So jockeying, reneging, bulking, we discussed about all those things, and mainly we discussed about the role of servers, that is the difference between servers and number of queues, number of servers, how it is going to affect the operational cost, as well how it is going to increase the operational efficiency. So these things we discussed in the initial part, that is still queue models. Then the next thing was with respect to analyzing the order picking and packing. So having a queue design, how the order enters into the system, how probability plays a crucial role in this regard, and how it is going to get packed and how it leaves the system. With respect to probability we discussed. As well, we discussed about the KPIs, that is key performance indicators, which are considered to be tangible in nature. Why? Because before and after the implementation of the system we wanted to know how the system functions. Okay, so that is where we can come out with a proper justification of ROI. So that is the thing what we discussed in the analysis and order picking part. Then coming for the next thing, bottlenecks and congestion point. So what does this bottleneck and congestion point revealed was like this. So the basic thing what we understand here is, we have developed an automated warehouse, but the thing is the performance of the warehouse is not to the expectation. We would have had our own thought process, and that benefit would have not been arrived. Why? Because the lack of fine tuning. First, for that we should know the bottlenecks. So that is what we learnt in the particular bottlenecks part. What is bottleneck, how that bottleneck comes into picture, and how can it be overcome, what all are the ways and mechanisms are there to identify the bottleneck, and how to mitigate, how to overcome without spoiling or without affecting the other process performance. So this is what we learned in the bottleneck. Then we learned about congestion points. The congestion point versus bottleneck are quite crucial. Why? Because bottleneck is caused by congestion point, and some cases bottlenecks may not be there but congestion points might be there. So with respect to aisle configuration we just learned in this regard, and how a queuing system can be employed here so that that particular problem can be overcome. So that we discussed in the bottlenecks and congestion point. The next two was with respect to SLM. So having a very good system, warehouse system, but still the service level is going to directly not only affect, it is going to influence the performance of the business. So that is what we learned in that particular regard, how SLA, service level agreement, is going to get affected. Okay, how it affects with respect to the context of a regular managerial aspects, as well as in the context of warehousing automation application also we discussed. Then coming for the average wait time and queue length, it was the problems what we solved. So owing to the time constraint, we just solved two problems involving all sorts of formulas, and of course we solved a little on the online platform, as well as much we discussed on the offline classes. So this is what we had in this particular syllabus, and now that is for unit 2, and now we are in the verge of completing unit 2, that is last presentation, forecasting queuing behaviors and how to identify the demand fluctuation, as well how to mitigate. So mitigation, how does it plays a crucial role? So all the associated part we will discuss in this particular slide, that is presentation, and this presentation will be the end of unit 2. So with this we will be finishing 3 units, and we will be proceeding for the further 2 more units. Okay, so with this summary, with this recalling of the entire unit 2 and the previous discussions, now directly let me get into the further presentation. So first thing, before we get into all these things, we should understand the term forecasting. What this particular forecasting term relates itself to, and what is this queue behavior, and how demand fluctuations are quite crucial in a warehouse case. See, first, forecasting is, it is a process of predicting. It is a process of predicting the thing which is going to happen in the near future. So in the near future, what is going to happen? It is mathematically it is done. It is not done by means of intuition or not by means of experience. Okay, it is going to be mathematically, it is going to be done. So there are several techniques are there against time, against technology. Likewise, there are several classifications are there. So first, understand the term forecasting. So forecasting means we are going to predict an activity which is going to happen in the near future. Okay, so near future means we can't call something which is going to happen after a decade. No, not like that. Okay, for a small period, say for example for the next quarter, that is next 3 months, next worst case next year, worst case, that is the worst case. So that is the time frame what you can go ahead with. So how we can go ahead with this? So now, before we get into the further discussions, we should have one particular important concepts called as fluctuation, seasonal load. This is very inevitable fact into the warehouse cases. All the seasons we may not be having eventual load. The load may not be equilibrium, and the load may not be same across the different duration. So there is a fluctuation is going to occur different because of different reasons. The first difference, the first important factor which is going to have a greater impact is seasonal demand. Okay, then the other important crucial part is the purchase capacity of the people. So throughout the year, people's purchase capacity or the requirements may not be same. So that is going to vary with respect to time. So with this theoretical background, with this theoretical understanding, so now we'll get into the actual topic. So forecasting queuing behavior and demand fluctuations in a warehouse automation system is critical part for maintaining efficiency, minimizing bottlenecks, and ensuring the right allocation of resources. Okay, so resources here means it might be a robot, conveyor, or some sort of mechanism, that is systems, or even it might be a human resource. So these all are considered to be resources. So now what is the critical or the crucial part here is, see, the efficiency is going to be affected. Okay, so now let us put a very simple example in order to understand this particular mechanism. So the first example here is, say morning routine, the shift starts or the cycle starts somewhere by 8 a.m. or so. Okay, let us put an example. So the moment you open up a system, we may not be having an order, or if at all we have an order, that is might have been placed somewhere in the non-operational hours, say somewhere in the midnight or early hours of that particular day. Okay, usually the warehouse may not be operating, so that particular duration. So the moment you open, chances are there for a pile of orders. There might be pile of orders. Some cases it may not be there. Okay, so based on the weekdays or based on the holidays, so it is going to differ. So that is what is forecasting queuing behavior. We are supposed to forecast. Why? Because then only we will be in a position to prepare for such worst cases. What might be the worst case? How should we equip ourselves in order to focus or in order to know that particular bottleneck. Okay, then second thing is demand fluctuations. Yes, load is going to fluctuate with respect to time. So how do you manage the resources when you have a peak load as well when you have a lean load? So this has to be considered. Okay, so why I am giving you so much amount of preamble in this regard is it is very important. Why? Because today's AI techniques are playing a very crucial role with respect to forecasting and other aspects. So the foundation and the theoretical understanding is quite essential as far as this topic is concerned. Okay, so high priority has to be given. That's the reason for summarizing all sorts of theoretical background in this particular regard. Okay, so now we'll directly jump into the further slides with the fundamental understanding what we had. So now, before we get into the process, we should know what all are the objectives. So the first objective is we should predict the queuing behavior. Okay, when and where queues from picking stations, packing stations, or ASRS systems. So what will be the queue behavior? The morning you open up in the morning, the moment you open up a system and you see pile of orders, under what circumstances are you going to accommodate this particular orders? Why? Because from 8 a.m. onwards we get some sort of uniform in a prescribed frequency we are going to get the orders as well. Already there is a piled up order. How do we resolve? How do we balance? So that has to be predicted. So in a very general case, morning, okay, this is how this many orders we can expect, means we are supposed to equip ourselves with respect to that particular demand. Then it will demand fluctuation means definitely it will be varying with respect to time. With respect to time, definitely it is going to vary. So on a simple understanding, initial month, that is say first fortnight of the month, the people's purchasing capacity will be on the higher end. So therefore we can expect good amount of demand as well. There will be consumption of FMCG, that is food based things. Consumption will be high in the initial starting fortnight of a month, but gradually that is going to decrease with respect to end of the month. Why? Because people's purchasing capacity is going to decrease. Okay, and again the cycle, again the loop is going to open up. So likewise we are supposed to be in a position to predict all these things and equip the system based on the prediction what we made. First, how do I do it? The first foremost cases, we should collect the data. The purpose of the data is to build predictive models. So queuing theory itself is going to confine itself with respect to numerical modeling, and forecasting is again going to be a subset. But as far as the syllabus is concerned, we don't have any numerical problems in this regard. But practically speaking, yes, forecasting is a very good interesting field where it has very good different classes of techniques are there for the case of forecasting in the presence of fluctuation, in the absence of fluctuation, based on probability, based on meta heuristics. Likewise, there are several things are there, but we are not going to do, or we are not going to deal with respect to numerical problems, but we shall discuss on the theoretical grounds on what basis are we going to develop the model. So first thing is operational data. So first is data collection. So within that operational data we are supposed to get, that is order time stamps. Order time stamps means inbound and outbound. Okay, so at what time we have got that particular product inside, and at what time that particular product went outside. What is the duration here? Some products might be lying inside the warehouse for years together or for months together, at least over a prolonged period. On the contrary, when you see some products might be like a hot cake, where they come and within least possible time they might be taken, that order might have been received by the customer and it would have been sent out. So this time duration for each and every product we should know. Then only based on that the model can be designed. Number one. Number two, item types and SKUs. So item type means what is the nature of type, whether it might be some chemically affinity oriented material or flammable material or degradable material, likewise whatever may be the case. And SKU is very important. Okay, store keeping units. So there might be some sort of reservations, we can't keep on the quantity as we like. Okay, though it might be having very good market, but still we may not be in a position to keep them as we like. So store keeping units has to be considered. So when you want to develop a model, first we should know the time, order time stamps. Second thing is the type of item type as well as the SKUs we should know. And storage and retrieval time. So what is the time necessary to store that particular product, and what is the time necessary to retrieve that particular product? For example, if they are very bulkier in nature, so obviously it will be very difficult for us to position as well as to retrieve them. So likewise, even that process we should have a thorough understanding. Then queue length at the stations. So average in a day or in a week or with respect to time, we might be knowing what is a queue length. Okay, queue length, not at the particular system. In one particular queue, what is a queue length? Average queue length. Okay, already we solved problems in this regard, numerical problems in this regard. So we should know what is the average queue length. Then based on that only we'll be able to plan. Okay. Then next thing is robot or the conveyor type travel times. So what is the time from that particular retrieval point till packing point? What is the time it takes? Okay. Then finally resource availability. So all these aspects has to be considered. So that is what I told. This flood queuing behavior or forecasting behavior involves good amount of data in this. Why? Because mathematically we are going to develop. So therefore, in order to provide a proper abstract of the thing which is happening in a physical system, we should have good amount of data. And now the next thing is, first we took with respect to operational data. So now we'll discuss with respect to external data. So external data here means the data which is not associated inside the warehouse, somewhere outside the warehouse, that is the population from which are we receiving the orders. Okay, external data. So seasonal demand trends. So it is very understood that all the products do not, all the products, okay, I stress it again, all the products do not have demand across the year. Okay, there might be some seasons which might directly influence. For example, let us get into some soft drinks, some beverages. So what is going to be the thing? So during peak summer, yes, the demand is going to be, obviously it is going to be in the peak. Perhaps when we migrate into say autumn or into monsoon or with respect to winter, the demand is going to be almost negligible. Okay, some cases maybe some minimum level can be there. So this is one seasonal demand. So likewise, even when you get into an engineering example like automobile, so post December we will not be having much demand. Why? Because the financial year end gets end over by March, so hardly left out with 3 months. So therefore what happens is the consumption will be very least, some meager consumption will be there. But post April or May, again the demand will be to the peak. Okay, based on the market forecasting, based on the privileges what government gives by means of their budget. So several factors do directly influence, so that has to be considered. Then promotional campaign and dates. So usually during festival season, especially somewhere from the end of September, because we get several auspicious functions across all religions. There are several festivals across all religions. So therefore, they will be coming out with a lucrative campaign so that they can sell their products at the earliest. Why? Because calendar year is going to come to an end. So therefore, the model gets outdated the moment when you migrate from December 31st to January 1st. So there are several myths what consumer has. So likewise, even that has to be thought of. Then holidays and special events. So today that is going to be one crucial affair where often you can see some peak demand is going to be there for the case of transportation, say railways, or you get into any omnibuses or even government operated buses likewise. So holidays and special events are definitely going to affect the warehouse processes also. Then weather, of course, this is another crucial fact. Say somewhere in the end of December or during December, obviously Tamil Nadu is going to get good amount of monsoon. So therefore, the consumption, everything will be maybe to the least, unless and otherwise they are so exigency that particular product might be having a demand. Why? Because only basic fundamental food related things might be having. But other cases we need to go with a thought process. So that is where this proper understanding comes into picture. Then second, first data collection, and now second, forecasting demand fluctuation. How do I forecast? So as I told you, there are several techniques over there. So the first technique is time series forecasting. So based on the time, okay. So time is going to be one crucial factor again which we can go ahead with the forecasting. In simple, you have a time frame, a common time frame, say from January to February. Okay. So this is on a macro case. Then again, January first week, second week, third week likewise, or January first day wise. Okay, if it is a weekday, if it is a weekend, so likewise we can go only against time. So forecasting will be done against time. So such models are called as a time series models. So against the time only we do all the things. So the time might be a calendar, or with respect to some sort of special occasions also we can go ahead with. But the obvious scale is time is going to be there. So the techniques available here is Arima or Sarima. Okay. Then Prophet, a software by Meta, or LSTM or GRU. Of course, they are deep learning AI techniques. Okay. So likewise, we can have several things. So the first is going to be time series forecasting. Then the next, forecasting demand fluctuation. The first method was time series, and second thing was clustering demand patterns. So we should understand the pattern, how the pattern goes, how it directly influences. We are supposed to have a thorough understanding with respect to clustering demand patterns. So we group them and based on that we go ahead with. So how we can go is within a day, how, what is the time duration. So morning, say from 6 to 8, what was the duration, then 8 to 10, 10 to 12, likewise maybe against some time we can club everything and we can understand the pattern, how it goes, something like a whether it is normally distributed or is there any skewness is there. So usually we call this as uniform bell shaped curve. Likewise, Six Sigma concepts, anything can be done. So the main thing is we can plan for some scenario. So the simple or the understanding is like this: during weekdays the morning will be quite vague, and at the end of the day there might be some good amount of demand can be expected, and obviously from Friday afternoon onwards till Sunday complete, so we'll be having peak load. So likewise we can plan. So that is called as scenario planning. So based on the pattern we will be coming out with some sort of crucial planning. Then the next, so first two cases time series we had, and then clustering concepts we had. Now how do we behave? So how do know the modeling behavior, the queuing behavior? So now two concepts come hand in hand. The first is going to be queuing theory, and the next is going to be simulation. So queuing theory and simulation both comes hand in hand. So that is going to help us to know the queue pattern as well as how the behavior is going to be in consumer point of view, how it is going to be. So the first thing is default we are going to use a Kendall's notation, that is a queuing model we are going to use. So this queuing model will directly help us to understand how the queue works, what is the rate of availability, what is the rate of servicing, and what is the waiting time. So likewise it will be offering us the input data. So such input data will be helpful to decide the service rate, and we can predict what will be the performance of the queue. So incoming we know and outgoing we know. So now we can come out with some sort of consensus so that we can come out with some crucial troubleshooting process. So queuing model is going to be number one. And the input is going to be obviously lambda, arrival rate, and service rate mu. So both should be equilibrium. That is what theoretically we expect. Lambda should be equal to mu. So what happens is there is no waiting in the queue. That is the general understanding, but practically it may not be so. Okay, so it has its own nuances in this regard. So theoretically we expect both supposed to be same, but both may not be same. Practically they may not be same. So there will be some sort of unbalance will be there. So that unbalancing can be balanced by offering number of servers. So you have got one server, based on the lambda arrival rate we can think of increasing the number of servers. Okay, so the output will be like this: average queue length, we can reduce the queue when you are increasing the number of servers, and probably waiting time is going to reduce, and the probability of queue exceeding one particular limit, again it is going to reduce. Okay, so one simple understanding is maybe when you get into some good supermarkets, at the end there might be say some 10 to 15 counters might be there. During peak hours all the 15 counters will be opened because you are increasing the number of servers, because you have got the queue length, waiting queue time is going to be high. Maybe during lean period, lunch period or something like that, when you see only one or two counters might be working and others will be kept closed. So this is one simple understanding by which we can accommodate the queue. Then the next, using queue model was number one, and the next is with respect to discrete event simulation. So it is also called as DES. So discrete event simulation is like this. So usually queue behavior is, on two cases queue may not be working well. Why? Because it is purely based on probability. So probability means there is a sort of risk associated with it. Okay, there might be working or it may not be working. So for it, what we need to do is we need to understand the process in a very thorough context. So for that, what we go ahead is we get into discrete event simulation. Why? Because queuing behavior as such, it is focused only on the input versus service versus output. So only three core parameters are essential, only three layers are involved into it. But how with the system performance? In a warehouse context, when you see, we have got a robot, we have got a conveyor, we have got ASRS systems, there are multiple systems are there, and human resources are associated with almost all the systems. Some cases they'll be only to monitor. So likewise, some inter-oriented networking based of complex and series of activities are there. So under these cases, queuing theory may not be working. On a very generic scale, yes, queuing theory might be working good, but when you get into an warehousing context, 100% queuing theory may not be working. So for that, we should go for an higher level thing called as a DES, discrete event simulation. So what is this discrete event simulation is? We should understand each and every subset. So a system might be consisting of several subsets, say some 5 or 6 subsets are there. So each subset has to be thoroughly analyzed, and the parameters, the notations, the functionalities, the KPIs, the performance metrics, all these things to be considered. Then after getting all the subsets only, we consider that as a complete system, comprehensive system, then only we'll be in a position to work out in all this regard. So for that, we need to have a higher level softwares in this regard, not just a queuing model will solve the purpose. So any logic we can use, Fluxysim, Simo, Simfy. Likewise, there are several softwares are there, or even Autodesk is offering Plan to 3D. Okay, then there are several visual components in our college. We have got Delmia, we have got. So likewise, we can understand the concepts. Then when you get into complex systems like ASRS or robots and conveyors, we have got another crucial concept called as the routing rule. So how the product routes, how it goes from one point to another. So likewise, we need to know the routing rule. So which point or which path will offer us the least possible thing. So two more techniques are there, that is based on operations research, PERT, okay, program evaluation review technique. So CPM, critical path method, these things falls under the network model. So even network models we can go ahead with. And we have learned about bottlenecks. Yes, bottlenecks will be there. Whether queuing model will be able to forecast this bottlenecks means obviously the answer is going to be no. So therefore, we can't consider queuing model to do all these things. So we need sophisticated softwares and technologies to carry out this crucial tasks. Next, combining forecast with operation. See, when we wanted to have realistic abstract of the physical system, so one technique merely will not solve the purpose. We should have some sort of combinations. Why? Because the reason here is multiple systems behave in a multiple aspects with different probabilities and functionalities. So one technique may not be solving the purpose of all these requirements. So therefore we should have some sort of combinations. So let us see what all are the combinations, and of course these combinations are going to help us in unit 5. So MCDM, multi-criteria decision making or decision analysis, MCDA. So this is going to have its continuation in the final unit. So first thing is we should have a real-time dashboard. So everywhere this dashboard comes into picture. So KPIs, monitoring KPIs. So monitoring has to be done in a dynamic case, not in a static case. Dynamic case and the frequency to be so low. So one simple case here, what is a real-time database, or a simple thing is Power BI. Okay, Power Business Intelligence offered by Microsoft. It's a open source only, we can use it. So graphs what we make by means of Excel or Origin or Sigma plot or standard graphs, those graphs are fixed. Unless and otherwise we modify the data, we change the data, those graphs are fixed. But when you get into Power BI, no, it is the mechanism itself is dynamic, where with respect to the change in data with respect to time, obviously these graphs are also going to change. Then the next is forecasted demand. So again, this is going to help us with respect to the forecast. So what will be the expected queue length? What will be the arrival rate? So it is going to help us. They are going to offer us good amount of data. Why? Because simulation as well as queuing theory as well as decision support systems, these three islands have been integrated here in order to get these things done. Then resource recommendations. So it is going to identify the ideal resource and it is going to reroute. So routing rules comes into picture. So routes are going to be defined. The paths are going to be defined, and therefore we can come out with a very concrete solution. So there are several technologies, Pythons, or as I told you, Power BI or Tableau, several softwares we need to use in order to understand the thorough functionality of the processes. Then the next step, optimization and resource. See, when you get into any of the engineering activity, the final step what it is going to land upon is optimization. Why? Because today the optimal trade-offs between two functions, that is functions versus cost, they are supposed to go hand in hand. Why? Because in our own earlier case, you have got a good amount of queue length, the queue in the waiting system, as well as the service time. When they are not hand in hand, obviously we need to increase the number of servers, channels or servers has to be increased. So obviously it is a one which directly associated with respect to cost. Okay, you can't often or always you can't have 10 counters. Why? Because we need to spend money on the system, on the infrastructure, on the resources. Likewise we need to spend money including space. Okay, demand is only 1 hour, only per day we are going to use only for 1 hour, means whether that process is essential has to be thought of. So that is another crucial case. So any engineering activity will finally get culminated only with respect to optimization. Okay, so this we need to know. So what all are the outcome of this optimization and responses? The first is going to be dynamic slotting. So dynamic slotting, so today you can see majority of the cases there is one particular aspect called as appointment. So against appointment only we'll be able to get service. For example, you wanted to get your car serviced, so prior you should have some sort of cushioning time. Say not tomorrow means not today you are calling, some 2 or 3 days ahead. If you call and if you get your appointment done, your car might become it might be picked from your own point. People will be coming to your own point, they will pick, they will get the car service, and they will be delivering you to the point where you request. So such a dynamic slotting can be done. Okay, this is an non-engineering example. So on an engineering example we can go ahead like this. So for bulkier products, one particular day will be reserved where all these resources, right from conveyors or human or robots, ASRS, will be focusing on that particular part. Okay, some flammable part, something like that we can go with some sort of slotting. Okay, or the products which are having high demand. Okay, such products can be thought of. Adaptive staffing. So today this is the need of our adaptive staffing. When there is a necessity, we'll be going for hiring of people, we'll be requesting, we'll be offering some sort of opportunities to render their services to us. So that is going to be adaptive staffing. Then robot task allocation. So robot task allocation is purely, earlier case it was experiential or maybe by means of experience, but today dynamic slotting is often extended to robot task, so that robots can be used when human in the absence of human. So likewise we can come out with some sort of creative as well as innovative ideas. Proactive identification and mitigation. So the first part is we have used a mathematical model to understand what is happening in the system and how to behave, how to predict the behavior as well as how to forecast the fluctuations. So now yes, we have understood based on some mathematical techniques. Now how do I mitigate? Mitigate is how judiciously am I in a position to address all those questions or all those queries. So that is what is proactive identification and mitigation. So usually any of the operations like call centers or retail checkouts or airport counters, anyway, queues can cause always inefficiencies. Always they are going to be inefficient. That too when you are having increased wait times and customer dissatisfaction. See, if everybody is getting served within some 20 or 30 seconds, nobody is going to face any issues. The moment they come, they get their service done and they are sent out of the system. When it is having pure birth and pure death process, we don't have any issues at all. But once the arrival rate is exorbitant and service rate is very poor, so obviously the waiting time is going to increase, the queue length is going to increase, then customer behaviors are going to be in problem, balking might happen, reneging might happen. So those things has to be considered and finally it leads us to customer dissatisfaction. So that is the core essence of this particular. So how to behave, or how do you predict all such things, and how do you counter upon all these things, and that is what is mitigation. How judiciously are we going to address their concerns? We can't just like that, we can't live. Okay, we are supposed to address all their concerns for effective business. So the first case is we can go ahead with anticipation in advance. So that is what forecasting comes into picture, so that SLM can be brought inside, service level management. What is the KPI? See, over one particular thing, everything got saturated means we can give a very clear statement that no, this is the condition, we can't offer any sort of extra services at all. So the servers are busy, and for the next so and so duration we can't go ahead with working of anything. Can be easily thought of, they can be nicely thought of, and it can be planned well in advance. Okay, so that proactive steps has to be taken. So that is the least possible mitigation what we can do. So first case is we are going to forecast as discussed earlier. So the mitigation step, the first step is going to, we are going to forecast the queue. So we can predict the queue length, wait time, or traffic volume using historical and real data, hybrid nature, or the queuing model, or the models can be powered like time series or machine learning simulation models. Likewise, we can forecast the queue. And the next step is identify how are we going to do. So scenario planning or scenario model can be done. Threshold alerting and anomaly detection, this is very important. So well in advance we can give a cautionary notice that the queue has already been saturated, so whomever comes will have a definite waiting period. So likewise we can go ahead with, I'll tell you one example in this regard. So there is a famous Tirumala temple which everyone knows. So there in their website, when you get into ttdsevaonline.com, the moment you log in, you will not be in a position to log in. Why? Because it will show you virtual queue time. Okay, it goes in a countdown fashion, it goes, and number of people waiting in the virtual queue, everything will be shown. So what is the significance here is we can prepare ourselves for the queue. Okay, I'll be in a position to get, I may not be in a position to get. So likewise we can draw some sort of conclusions, or we can try logging in other systems, or we can come out with some sort of conclusion, so that it guides us, it gives a proactive measure. So this is one of the mitigation. Once you are unable to 100% fulfill the needs and necessity of the customers, we can go ahead with some sort of early warning system. Okay, mitigation. So we should do timely action. See, when the action is taken in the right time, it is going to reduce the impact of the forecasted issues. You are not giving any sort of warning, there is no beacon or anything, there is no safety mechanism in this record, means obviously it is going to lead to customer dissatisfaction. On the contrary, you are thoroughly following the forecasting cues, and those issues have been let known to the customer. See, only 100 people can be accommodated. Right now we have got some 101 or so, so we wait somebody to get their service done, and we wanted them to leave the queue. So based on that, we'll be able to accommodate, means you are giving away the real ground level situation. So now the customers are having a veracity, trustworthiness on the system, and you are not going to lose the business, and in turn it is going to be an indirect advertisement. So likewise we can go ahead with, but not all the case, some cases. Okay, so we can go ahead with some sort of token mechanism, we can give them batch mechanism. Like this we can come out with some sort of mitigations. Okay, so now we'll see what all are the techniques are there, what all are the tools used here to do all these tasks. So the first thing is trend analysis. So trend analysis, it is going to identify patterns in demand before they peak. See, the main purpose of mitigation is something like prevention is better than cure. Okay, that is the underlying phenomenon of this particular mitigation, not post syndrome. The syndrome has come and it has made all this possible spoil port, and it has completely spoiled all the repeat, means not doing then. So in a very advanced case it has to be done. So for that we are going to use this, say Power BI dashboards can be used before it matures, before it reaches the peak, we'll be in a position to understand, and time series tools are going to be highly helpful in this regard. Then anomaly detection. spotting irregular spikes or dips that may indicate problem. So there might be some time frame where when people, the society is free, there might be fluctuations or demand, high demand in this regard. So we'll be able to understand that clustering aspects. So that is where ML algorithms or threshold activities will help us to solve the process. What if simulations? So this is another fantastic area. So now what will be the worst case if the same situation prolongs? So we can go ahead with, okay, it need not to be worst case, even that might be best case. To come out with one particular example here is when when cricket games are under process, so you can see RPO, run rate per over. Then there will be one particular, if the same run rate goes on like this, the score might be going to an Himalayan task, say some 400 or something in a 50 over match. But that may not be true, but it is going to help us if the same. So the condition, underlying condition here is if the same runs per over, run rate per over is persistent, if it is constant and consistent, we are going to get good amount of outcome. On the contrary, if the same, say, poor run rate, means it is going to tell what will be the worst case. So always it need not to be worst case, even it can be best case. So it is going to help us in testing the scenarios like staff shortage or increased demand. So queue simulators, so very simple queuing models or queue simulators will solve the purpose. So the next is early warning system. So early warning systems are highly anticipated in today's industrial need. So forecasting, okay, A and ML techniques are going to help us a lot in this regard. So first thing is it is going to trigger alerts based on forecast thresholds. So if the same trend goes on, say by 12 a.m., okay, of course 12 a.m. is mid, so 12 p.m. in the noon we can expect good amount of peak in customers. So if we can go with some sort of proactive mitigation measures, so that that is not going to damage or it is not going to hamper any of the repute of the automated system or the queuing system what we have developed over time. So now it is going to be a destination. So forecasting behavior, is it going to be a destination or a journey? When you see, definitely it is not going to be a destination, indeed it is going to be a journey. So it is going to be a continuous loop process, not you do on one day and you just stop, no. Okay, so on a day-to-day basis it is not going to be a destination, it is going to be a journey where continuously we are going to work in this regard. So first cases, we forecast, predict future queue patterns, monitor real-time tracking of actual versus forecast, trigger, identify risk of SLA breaches, service level agreement breaches. So earlier we have fixed KPIs, whether those KPIs are not met, identify the root cause, do the trend analysis, identify, troubleshoot what is the cost for that particular problem and try to mitigate them. Then second case is do corrective actions. Yes, agree, first of all agree, yes there is a problem, then how to come out with the corrective actions we can go ahead with, and finally evaluate. You would have adopted, we would have adopted different models and we will thoroughly analyze what all are the different outcomes have come and which model has done best and which has not performed to the expectations, and all such thought process can nicely be brought here, and so that the entire process of queuing system, the benefit can be reaped, so that optimized, the best warehouse automated system can be obtained by the application of these techniques. So final slide before we go ahead with, let me summarize. So this presentation took us to the strong understanding of the queuing theory and the hybridized nature of the queuing theory versus forecasting models. So we discussed about two different types of forecasting models. The first was with respect to time series and the next was with respect to clustering or the pattern analysis. So post learning them, we just dwell into the different needs and necessities, the bottlenecks, the congestions, the activities which are going to directly influence the system as well as the formation of queues. So what all are the corrective and countermeasures which we need to adopt, right from human factors, then to technological factors, then to the layout configurations. So across all streams of the systems we discussed. Then finally we discussed about the proactive measures. What all are the countermeasures we can go ahead with, and how to get an optimized systems was the discussions in this particular regard. Okay, so with this summary, now we come to the end of the presentation. So what we discussed in queuing theory, the complete unit was with respect to modeling a queue, which is going to represent the, or it is going to act as an abstract for the entire physical system. So the notations involving right from lambda, arrival rate, mu, service rate. Then we discussed on several problems, that is numerical problems in this regard. Then Kendall's notation, when one server is there with uncertainty, when multiple servers are there with uncertainty, was the initial part. Then we migrated into how to use or how to implement the same queuing concepts into a warehousing automation application. And the very crucial part was how to analyze the picking and packing orders. So they both should go hand in hand. So that is what the phenomenon was. Lambda, arrival rate, is equal to mu, the service rate. So both should be uniform, but definitely that though it is an expectation, that may not be uniform. So what will happen? What are the adverse effects? So when lambda is not equal to mu, so obviously the arrival rate is going to be high because of the poor service rate, or standard service rate, let me put like this. So the waiting time of the system is going to increase, and the queue length is going to increase. In turn, the system's service time is going to increase, and that may lead to congestion, and that congestion will convert itself into bottleneck with respect to time. So the next was the mitigation measures. So how to mitigate that? Yes, an issue has occurred, how to go ahead with the mitigation, so that we learned. And another important concept here was the forecasting. So before the trauma has hit, how to safeguard ourselves from such negative ill effects we discussed. And other important things here was with respect to discrete event simulation and with respect to time series simulation we discussed. And the drawbacks of both these things we learned, where time series was doing only with respect to time, but discrete event simulation was quite better. Why? Because it was involving multi subsets, and it is going to give a comprehensively good abstract of the entire physical system. Then finally, what all are the proactive and mitigation measures we can go ahead was the discussions what we had. So with this, we completely finish unit 2, queuing systems, or queuing theory, and how it can be implemented in a automated warehouse, and how we can reap out the benefits we just saw. Okay, so with this we come to the end of unit 2 as well as chapter 6. So with this we finish unit 2. So students, as usual, any doubts you have got, please note it down. We shall discuss the same on the offline classes, or on the convenient online platform, online classes we can discuss the same. So still, if you have any doubts, please meet me so that the same can be rectified. So before I wind up the session, this presentation, thank you students, thank you for your kind patience, and happy learning. Okay, thank you one and all, thank you once again. So in another presentation, we'll just start afresh with next unit, unit 4. Thank you all. Bye. Thank you.